hi everybody. And yeah, I'm going to talk today about packaging for recalls, or what happens when something goes wrong. So not going to belabor this too much, but for me, my background comes from security and then some performance, and then sort of back into security. And today I deal a lot with vulnerabilities in open source components, and how can you sort of handle them and address this. So this talk is kind of touches a little bit on that space, but nothing more. And actually, this whole talk is a little bit of a metaphor by itself, talking about recalls and the meaning of that, and how does that sort of transcend from physical to virtual. So as we know, products are never perfect, right? Even when you take and put them into sort of a very nice package, they oftentimes have flaws. There might be some mistakes in them. In the software world, those might be vulnerabilities. There might be security flaws in them. I say might be, but it's almost an eventual inevitability that those would happen. So what I'm going to talk about is what happens when something goes wrong, right? And this talk is going to use the physical metaphor of recalls. And we're going to go through recalls in physical products, which I think kind of is the concept of how we think about a recall. It's a physical product that got recalled. But then we'll talk about how does this metaphor, or how does this concept apply to commercial software, and then subsequently to open source software. And what succeeds there and what doesn't. And there are probably a million ways to sort of slice and dice this, but I'm going to talk about 3 questions about a recall, and then try to go through each one of these 3 levels, because it's 3, and that's how you're supposed to do it. And I'll ask what warrants a recall. So why do we recall it? What's bad enough to it? Who decides that? How do you find out about a recall? And then who's responsible? There's some inconvenience caused here, small or big. Who's to blame and what happens there. So we'll start with physical products and talk about what warrants a recall. So there are various types of reasons to drive a recall. Maybe the biggest one, or the ones that is easiest to identify with, is a safety recall. We've seen a bunch of examples of this in the physical world recently. You might remember in 2011, this actually dragged into 2012, Toyota recalled about 10 million cars because they had a sticky gas pedal, which sounds a little benign until you're in the car where that gas pedal sticks and continue. That was a pretty big recall, caused a lot of sort of brand damage to Toyota, a lot of conversation about it. It was actually pretty small compared to something that didn't make quite as many headlines, which is GM's recall of almost 30 million cars because of an ignition switch failure, which again doesn't sound that bad until you realize that it may shut off the engine during driving and thereby prevent the airbags from inflating. And in fact, this flaw, this problem, was linked to 124 deaths. So, in both of those cases, there were real kind of incidents that were tracked back to this flaw, and that drove a recall, right? That's almost an obvious one to say that it's a recall, but a lot of mistakes and bugs or sort of problems in a product that may not level up to something that requires you to recall 30 million cars. There are other versions of this that are still in the physical product but touch on software. So we've probably all seen last year, or 2015 actually, the hack of the Chrysler Jeep, that the reporter was in it and a couple of guys kind of hacked into it in Black Hat, and it was disclosed in Black Hat, and took over the engine while he's in the car. Not fun and a little stressful. So that drove a recall of that specific type of car. For a software flaw, but it was still a physical product recall, right? The software components are just a part of this physical product. You bought it, you don't really care, whether it's a software component or mechanical or whatever it is. It's a part of your product. It needs to be recalled and either fixed or replaced. So in these cases, oftentimes in these recalls, it's a recall as in you bring in your car, and sometimes they need to take it back and give you a new one. Sometimes they fix it. There's not all cars. Recalls do happen elsewhere. One of the ones that you might encounter today in PA announcements is the Samsung Note 7 recall about the battery, that it may blow up, this sort of minor issue, but it may blow up on you, and it did actually multiple times. And so badly that you're not allowed to bring that type of phone onto airplanes today because it may cause an issue. So that triggered a pretty substantial recall of that sort of a hardware device, but is heavily software. And we'll talk a little bit about damages in a moment. And then recalls also go into sometimes in some devices, any flaw is recall worthy when those devices are very, very close to health to begin with. So if it's a pacemaker, if it's a defibrillator that's implanted, like the case of this St. Jude device, there was a battery depletion problem, which meant the battery may not be there to do exactly what it is that it was put in place to do, and that causes a recall as well. And again, it was sort of triggered by 2 associated deaths. So those are examples of sort of safety problems. They may hurt somebody. Just as an anecdote a little bit, this happens in beer as well. Corona actually recalled about 1 in 5,000 bottles, which is actually not a small number of bottles for distribution the size of Corona, but they couldn't get the actual double because they may contain shards of glass inside, which doesn't sound fun as part of the, maybe adds to the flavor or the experience in a different way. So safety is the primary reason that we do a recall. We'll talk about this in software in a moment. The second type, which is a little bit less well known, is quality recalls. And this is the cases where it's an actual manufacturer decision to say, hey, there's a quality problem here. It's not going to make anyone die or get injured, but it is a problem that may hurt me. It may be less damage for me to recall this now than it is to not do so. So I actually have one example of this, which is beer. And this is the Revolution beer recalled about 10,000 barrels because they exhibit ester or phenolic, I don't even know what those means, flavors, which are more characteristic of Belgian-style ales and which should not be present in our standard American ales. Obviously, this is recall-worthy, or at least it was obvious to somebody that this should not be there, and they kind of made the decision to do this expensive recall because the beer doesn't taste as it should, and they think that overall, over time, that would do it. So that's sort of the second type. I don't want to think about ester or phenolic flavors when I taste my beer. And then last but not least is recalls that are external. They're about regulations. They're about broader impact. Your specific product might be fine, but it may be hurting something else. It may be hurting the environment. And probably the best examples, I've got 2 examples of those, both very high profile. One is Volkswagen, where they're recalled 8.5 million cars who can cheat emission tests, right? This just happened a little bit last year, or it actually started the year before, where the software, it's a software problem again, or sort of the way that the software was built on the cars, basically cheated or just sort of helped it get through some emission tests, which meant the cars were more polluting than they actually stated they would be. There's also all sorts of indications this was known. And this may have affected up to 11 million cars. 8.5 was sort of the formal number that I managed to pull. So this is an example where the car functions fine, but it is causing global damage. And in this case, what warrants a recall is a regulation. It's an external entity that came in and says, no, this product does not meet the needs, so the formal necessities of it. You have to recall it. Different flavors of it, flavor of this that we're seeing, and we will see more and more, is the IoT security flaws. So in the latest, like last year, in this Dyn distributed denial of service on Dyn that took down the internet for a while, we've seen many like refrigerators and webcams and such participate in taking down the machines. And it creates a very interesting ownership question and systems question around who's responsible and what's going to happen about it. And in this case, the primary vendor named in the researchers around this was this webcam manufacturer, the Chinese webcam manufacturers, Gami, probably not pronouncing it right, that had a security vulnerability in there that was allowed for these devices to be there, to be hacked, and then those devices were used. So I like the comparison here to the emission aspect because the devices work fine. They may or may not be used to sort of damage your house. Maybe that's a safety issue. But they can be used to attack others. And this is a type of problem we're going to come across many, many more times. But it's not as well understood, or we don't have a frame of mind. We don't have maybe metaphors for it like we do for emissions or environmental damage. There's no Kyoto agreements around what can you do around security vulnerabilities in your IoT devices. So I'm going to sort of finish my level setting in a moment by just sort of touching. Oh, this should have actually highlighted second problem is how are owners notified? So these are all sorts of problems that you might happen. How do you find out about it? Well, so the reality is that there's no really one good way. If it's big enough, it makes the news. You might have heard about it that way. And then maybe at that point, or maybe earlier on, you might have registered your product with a vendor, so you might get a proactive notification from the vendor. And then if you need to check it, and this is sort of a good example is this iPhone battery problem that's going on right now, you might be able to go to a vendor website, put in your model number to sort of understand the device and understand whether or not this product has been recalled or you're entitled for a replacement. And a little bit in specific fields like emissions or like in medical devices, there are sometimes public registries like the FDA keeping a list of recalled medical devices that are out there. So, not super interesting, but we'll get about the delta for this for software in a moment. So this is how you find out about it. They're not great ways, but those are kind of the ways that we got used to. And they work better for bigger purchases than they do for smaller purchases. And then last but not least is, what do we do? Like, who's responsible for these things, right? You go in, you buy a car, it had a problem. Even if you didn't manifest the problem, even if it was fixable, you still had to like drive it to the shop, and they had to do something to fix it, come back. There's an inconvenience you did not sign up for. And then, of course, there's the bad examples, the 124 deaths that were associated with GM's accident. Who's responsible? In the case of physical products, you bought the product from somebody. There's a very, very clear entity to blame. You look at Toyota's recall of the sticky gas pedal, they paid $1.2 billion in fines for this. You look at GM's action, they paid $1.5 billion for it, which actually I find fairly small as compared to Toyota's given the number of deaths associated with it. The Volkswagen issue, which is different, actually had some nefarious action in it, so they're actually, this may not have ended yet, but they seem to be paying at least $15 billion for this mistake, and beyond whatever ongoing damage for it. I don't have numbers for the beer example, but I did have the guy from Revolution, I guess the person that decided to do this recall, say that it's like a death in the family, so they paid for it in other ways. And then the Samsung example, it's estimated that overall it cost Samsung over $5 billion to do this. So there's a very clear entity that needs to pay. You bought the product from somebody, is there. Let's get a little bit murky over time. So one sub-question is, when you look at this example, Samsung actually stated after analysis that the problem with these devices was not something Samsung manufactured, but rather the battery that they purchased from two vendors. And do you care? You don't care. You bought the device from Samsung. Anything else past that is their responsibility. So they can go ahead and sue that battery manufacturer if they want, but you want your money back or whatever compensation from Samsung. Similarly, Toyota had a different recall. There's many of these. It's a little alarming when you go through this to find out how many of them are there. Pulled about 6 million, this is actually January of this year, about 6 million cars because due to faulty Takata airbags that they had in the system. Actually, these faulty airbags influenced about 23 million recalls, or drove 23 million recalls across 12 car makers so far. There may be more. But once again, who do you blame? You blame Toyota. You don't know Takata. What is this company? You bought your car from Toyota, and if the airbag does not inflate, or if there's a risk of it, you blame Toyota. So they own the manufacturers. So this is baseline. This is recalls in the physical world. Let's look at software. So first of all, what warrants a recall in the world of software? So safety recalls, a little bit less likely. They happen, but they're only for specific software that has a safety implication. So they're a little bit less so. Quality recalls, probably at least as common, if not more. We iterate more in software, so there's more likelihood that there's going to be a flaw because it's, we sort of rely on the fact that we can fix it faster. And then global recalls, as I just discussed, are probably even more prevalent, and it's a less understood space, but it's more about vulnerabilities or your machine used to attack or cause damage to another system. So recalls definitely still matter. But can you think of a software recall example that happened? It's not a physical product. We don't really have those because in the world of software, recalls were replaced with updates. There is no recall, there's just an update. You've got an update. And that messes things up a little bit. It turns the question of whether something is recall-worthy to whether it's update-worthy. And the answer to whether it's update-worthy is almost always yes, right? We continuously ship software. We always ship software at whatever frequency. And it's a different model. It's a different frame of mind, maybe a different metaphor. So what does that mean? Like, does that mean that we should always update? There's problems with updating. When you take update, you introduce change. And change introduces risk. And sometimes you don't want to take that risk. Is there value for you to take it? So there's no separation in the systems that we have right now, in the packaging systems and the consumption, around updates, which updates are nice to have versus which ones are recall worthy, right? Which ones should not be used anymore. There's some subtleties in here. So there's one delta of it, security updates. So security updates maybe roughly equal a recall. There's a security flaw here, so this is an update you should apply more urgently. But oftentimes they build on regular updates, and even then there's potential problems. This is actually an IoT example, but in 2016, so last year, in March, HP issued a security update to their printer that presumably actually fixed a bunch of security flaws. But inside of it, it also had a time bomb that in September modified the printer to not support non-HP cartridges. It was a sneaky move, not well accepted, was kind of called out for it, but nothing happened. Like, this was just noise. Is this legal? Is this legit? Where does this fall? But it's just another manifestation that any update introduces risk, including security updates. So in software, we lost this idea, or sort of the spirit of the law in the case of recalls. We just sort of went from recalls to updates, and from updates, within updates, we lost recalls. We lost the idea of understanding what is the driver for urgency. And I think this is sort of a problem, whether commercial or open. Let's look at the next aspect of software, of recalls in it. How are owners notified? So in the case of commercial software, there's really no change here. So it's basically the same as physical. If it's big enough, you hear about it through the news, some big Microsoft issues, some big whatever. If you're registered, you might get an email, and you can check the model number, or sometimes it's the software version number that you have on the vendor website. So that front, I think we're about the same. And then lastly, who's responsible? And in the case of commercial software, it's, again, the same thing. You purchase something from a Microsoft, from an IBM, you bought the software. If there's a problem, it's their fault. You probably have it in legal writing, and you can sue them, right? Or you can kind of get compensated by them. And also, similarly, although this is not as well rehearsed, the vendor is also responsible for whatever third-party component, including open source component, that's in their system. Now, in physical world, this is an area that it differs a little bit in legality. So in the physical world, there's a lot of laws around the bill of materials and reporting them. And oftentimes when you try to certify a car that you're about to ship or any device, then you need to show the bill of materials and show it has no known flaws. And there's actually a law that's going through Congress in the US right now about the cyber supply chain that talks about that type of notion in software as well, but those are not as far along. So that was recalls in software, and primarily the point there is around that sort of loss of the recalls in the update mess. And the last bit I want to talk about is open source packages and how the recalls work there. So first of all, I want to put aside, this kind of relates to the panel conversation before, foundation-backed or corporate-backed open source projects. As far as I'm concerned, those are commercial projects. They're not commercial in the sense that you're paying for them, and there might be less or more legal agreements between you, but there's a commercial entity behind it that is driving revenue from it, or sort of some business value from it, and typically you have somebody to sort of point the finger at, somebody to expect it. There's legal, there's license and all that around what it is that you are kind of indemnified for or whatever. But I'm talking more about all the rest, all these smaller projects that are around. They're not the 43 or whatever that are covered by the Linux Foundation. There are the 43,000 that are not. So for those, let's go through the list. What warrants a recall? So for the most part, this is software. Once again, quality, security flaws are the same. Safety a little bit more specific. And like commercial, recall equals updates. But updates in open source are a little bit different. So we have versioning in open source. And we use versions to sort of indicate what's the next, because you can't unpublish stuff. Open source is this registry when you publish things, but you don't have a way to retract them because of the stability, because of the way the system works. Unlike commercial software, which you can stop providing. You can just cut it off and say this version is not sent to any new users, to any new customers anymore. And we use all sorts of semantics, like semantic versioning, to understand the implications of updating. So they integrate the sort of update complexity, but there's nothing in there that indicates update urgency. So this is sort of the same problem as we see in commercial software, but maybe a little bit with a twist, because this has to be a little bit more standardized in open source. The other question around open source recalls is who decides which flaws are recall worthy? When you look at open source, oftentimes these components are small. They do something very specific, and they might have a missed behavior that is entirely legit in one case and is an entirely massive flaw in the other, right? If you lose like a bunch of the static serving packages in Node or in NPM have directory listing on by default. it's a legitimate decision. You browse to the site and it can show you all the files on that system. It's a legit decision for a package, but it might be a severe security vulnerability for somebody else consuming it. So is it the author's responsibility to indicate these things and decide whether there is a problem and whether it's recall worthy, or is it the consumer? Is that sort of the person using this open source component? Similarly, there's no dedicated security update indicator. So we have security update lists, we're used to that, but actually these security update channels are not created by the author of the security component, they're created by the operating providers. So it's Red Hat or it's Canonical that are curating and building these security update lists, and in fact, even building some of the fixes themselves into these channels to create them. So it's this third party, it's like a new player in here. You've got the consumer of the package, you've got the producer of the package, and then these recall indicators, these urgency indicators are actually created by a third party in between that you trust. And those actually work fairly well for the binaries on sort of a Red Hat or such platform, but they're only specifically focused right now on open source binaries. So it still leaves a lot of the open source sphere unattained, like open source code packages, like the projects themselves that you might download from GitHub. There's no vendor. The responsibility is murky. So this is about who decides the recall and what's recall worthy. Next question is, how do you find out about it? So, the one bullet that remains the same is that if it's big enough, you'll hear it through the news. Heartbleed kind of gave us a very, got 2 more minutes. But many of the other components we had in commercials go away. So there's no registration, so you can't proactively get a message. There's no vendor website for you to sort of go and check the solution in. So we have a few things that work for us. We can use deprecated indicators. That's really our closest thing to unpublishing, to say this is a recall, this is not usage worthy anymore. You shouldn't be using this, really. You're making a mistake. That's a good one. It's actually one that probably should be backported into commercial software. But in those cases, you just remove the download from the site. We've got some OSS registries and tools. So, again, sort of that Red Hat and Canonical and such sort of repository of security updates. You might have CVEs, the databases, which are hit and miss around their usefulness. There's some specific channels. We do that, for instance, at Sneak, that are focusing on package vulnerabilities. But again, sort of these intermediaries. And then lastly, and maybe the biggest delta in the world of open source, is there's no vendor. So there's nobody to blame. There's nobody that sort of pays the price for the fact that there was a flaw. And that's legit. There was also nobody paying a price for using this in the first place, right? You got it for free. You're using it for free. You're getting business value for free. At the same time, you got it with no responsibilities. There's no authority here. It's on you to address this. So the OSS package consumer is the one responsible here, which is maybe the biggest changes. So this is, hopefully, I hope there were some useful kind of perspectives, but looking at recalls and understanding how they manifest in commercial software and in open source software. Let me kind of recap what I tried to convey as takeaways from this, just to sort of show at the top. First, recalls are necessary. So the notion, the problem of a recall, the imperfection in a shipped, in a packaged product exists in software just like it did in physical. They're relevant in software that is commercial, and they're relevant in open source software. And in the world of software, open source recalls are lost amongst updates. And that's, I think, a problem for us to try and take on and sort of understand how do we better communicate the updates that are nice to have versus the ones that are urgent to fix. So that's sort of need one, right? To sort of understand how do we better highlight the versions that are unsuitable for use. Second is that in the world of open source, recall ownership is inverted. It's really about you, the consumer of the open source package, that the responsibility lies to track these things, to understand the flaws, and to be able to kind of go back and do something about them once it's there. It's not on the vendor. You're getting these goods for free, conveniently, and now it's on your responsibility to track them. So we need third parties to step up, like what happens again in the open source world. We need more registries for tracking these types of major OSS flows, and we need the tools to make that easy and at the end of the day, make it convenient, right? We need to find a way to make tracking and fixing these types of recall-worthy flaws as easy as it is to consume them, right? We need a way to return the package and to identify when you need to return the package as easily as you've sort of received a package with a flaw embedded in it. And then kind of last but not least, we need to make like as a norm, maybe sort of summarizing all of this for the open source side, we need to make this ownership, this responsibility for what it is that you're using a natural part of what you need to do when you use open source. How do we sort of instill that into people's minds that when they consume a package like that, they've undertaken some responsibility for sort of its well-being in their systems over time. That's it for me. Thank you.